Hi everyone. So a few videos ago, I demonstrated how we extract mugshots from an image. And as part of that process, I showed you how we associate a year with each of those images, a year that we think the image was actually taken, so that we can then use that information to order the mugshots from youngest to oldest for people who have multiple mugshots associated with them. So in this video, I actually want to bring in a machine learning model in order to do this. So there are several open source datasets available, such as the UTKFace dataset, the IMDb wiki dataset, and several others. The issue with these sort of datasets is that they are generally provided for non-commercial use, so just for learning purposes. And then there are other open source models available as well, so such as DeepFace, MiVOLO, and AgeNet Cafe model. Again, there are specific licensing requirements around these models, particularly the DeepFace one, which incorporates other models within it. And so if you end up using them for commercial purposes, then those sort of licenses apply. What I'm planning on doing is just bringing in this machine learning model so that I can learn how to build a machine learning model for the purposes of estimating the age of a person. So I don't know how it will pan out. It is a learning process, so we'll see what ends up happening. A disclaimer before we begin. I do not have access to peer-reviewed journals or conference papers. All I have access to is whatever the authors have provided, publicly available content, and archive papers. So whatever I say here may be incorrect or outdated, so just keep that in mind. So to begin with, I decided to look into the datasets and see what was available online, what I could actually access, and see which ones were actually good for my purpose. So I found UTKFace, IMDb wiki, Adience, Legenda, and the lab datasets, Adversarial, and Apparent Age version 2. I also found papers discussing morph, and I would have liked to have looked into that, but I couldn't actually find the data set available. So firstly, with the Adience dataset, I decided to dive straight into the 2013 paper on age and gender estimation of unfiltered faces by Eran Eidinger, Roee Enbar, and Tal Hassner. The dataset was actually constructed by taking 200 albums from Flickr, running a face detection algorithm over it, and manually annotating age, gender, and identity. According to the paper, around 30,000 images were provided in 8 buckets. The IMDb wiki dataset was constructed by crawling Wikipedia and IMDb for a list of actors and scraping their associated age, gender, and other details. Then what the authors did was, for each image that was associated with that actor, if that image had a timestamp associated with it, and if that image only contained a single person in the frame, then they assumed that that image was of that actor, and using that timestamp information, they dated the actor. So they assumed that the actor in the frame was the age of that timestamp minus their date of birth. So that's how they constructed that dataset. Now, the authors said that they did not provide any guarantee that their labels were correct, but it was just a massive dataset that they were able to build up with these potentially correctly labeled images. And this was according to the 2015 DEX Deep Expectation of Apparent Age from a Single Image paper by Rasmus Roth, Radu Timofey, and Luc Van Gool. The lab datasets, Adversarial and Apparent Age version 2 were competition datasets. I wasn't able to access the paper associated with the Adversarial dataset, and the Apparent Age version 2 dataset didn't have a paper associated with it. But according to the descriptions from both of these datasets, identified that there was some sort of crowdsourcing process for labeling each of the images. The next dataset that I looked into was UTKFace dataset. There was an associated paper with this. So that was the 2017 paper on age progression regression by conditional adversarial autoencoder by Zhifei Zhang, Yang Song, and Hairong Qi. Now I think it is related to UTKFace dataset, but I might be wrong. Now, this dataset was actually constructed by searching for a set of keywords such as 15-year-old boy, and scraping all of the images that popped up and using the caption associated with those images or an age estimation algorithm to actually figure out the age of those people in those images. So again, I might be wrong with the association of this paper with the dataset. Maybe there is a different way that they constructed the dataset, but that was all of the information that I found. Finally, the last dataset that I looked into was the Legenda dataset. This was the only dataset that I found that was available for commercial purposes, at least according to their license. Now, this dataset was based on the 2023 paper MiVOLO multi-input transformer for age and gender estimation by Maksim Kuprashevich and Irina Tolstykh. Now, the Legenda dataset was created by randomly sampling images of people from the OpenImage dataset and using a rigorous crowdsourced annotation process to label each of the images. Essentially, each participant was asked to label 70 images with 7 controls and with crossover with 10 other annotators. And the age associated with each person was determined based on a weighted average based on how well the annotator performed on the controls. I think it was well done how they had actually constructed this dataset because they had really gone into a lot of effort to make sure that the annotators were labeling things correctly. Now, after reading all of the papers and checking out the websites associated with each of these datasets, I decided to use all but the UTKFace's dataset. I just wasn't happy with how that dataset was put together. And in saying that, I did use the IMDb wiki dataset, even though that had a flimsy methodology as well. I found that they had explained it a bit more, and I thought it was worth having a look at it. So after I had selected my datasets, I decided to do a bit of an EDA on it just to verify that I could actually access these datasets and make sure that their content was fit for purpose. So I decided to begin with the lab datasets, so the Adversarial and the Apparent Age version 2. It looked like they were built from the same set of images. However, the Adversarial dataset seemed to have real ages associated with the images, and I'm not sure how they got that information. I wasn't able to access the paper to actually understand that. So both datasets had color images with different aspect ratios. They've tried to focus on a single person per image, mostly face crops, but there were also a few body crops as well in there. So both these datasets also have similar distributions in terms of age and standard deviation, with a mean standard deviation of 4.5, indicating that there was little variance in the ages annotators were associating with these images. There were outliers exceeding 14, which is very high. So I decided to look into some of the data with high variance, so variance between 8 and 10. I couldn't find any issues with the subset of data that I had looked at. The ages seemed to be okay around what I would sort of expect. Now, when I looked into variances higher than 10, then I noticed one extreme example where there was an image of a mother and a child. And the variance for this one was 14. And obviously, the annotators couldn't agree whether they were aging the mother or the child. So the high variance there sort of came from the ambiguity of who the annotators were labeling. And this sort of showed one of the problems with relying on just the average age and why you wouldn't want to necessarily trust the high variance score. I did also look at a subset of images with a variance of 0. And what I found was that they were mostly pictures of babies or where there was a cake or a card or something that identified the age of that person. So as part of celebrating a birthday, you would have candles and, annotators could count the candles. And so these pictures got a low variance of 0. And that was sort of to be expected because the information was all provided. Because of the distrust in the high variance data, I decided to just look at what it would be like if we excluded all standard deviations above 5. And I found that we went from around 7,591 images to 5,102 images without any changes to the distribution in terms of age or standard deviation. The Adversarial dataset also had that age attribute, and I compared it to the average age. And what I found was that in most cases, or in the majority of cases, annotators were within plus or minus 5 years of the real age. But there were outliers where annotators were off by about 40 years. And this didn't seem realistic. So I dug into this and I found 3 examples where the real age was blatantly inaccurate. So and that's not even reflected in the variance data. So the variances for them weren't as high as you would expect a deviation of 40 years to have. And it was just because the real age was incorrectly assigned to these images. And so for my purposes, I feel that because we have the average age and the standard deviation to see what the error, the variance in the error, it's better to trust the average age and the standard deviation than it is to just rely on that real age as the real age. So for training purposes, I would just rely on the average age and filter that down by the standard deviation if I need to. Okay, so the next dataset that I looked into was the Adience dataset. Now, this was a dataset that was produced by scraping Flickr. So the authors haven't actually provided us with the actual images that were scraped. They provided us with the processed images. So there were 2 folders, the faces and the aligned. Now, the faces set of images seems to have had the least amount of pre-processing done to the faces, whereas the aligned set of images seems to have had a lot more pre-processing done, where they have identified facial landmarks and then tried to align the face based on those facial landmarks that they had identified. So both of those data sets they provided seem to have a uniform size. So in addition to the faces and the aligned set of images that they have provided, they have also provided 2 sets of labeled files. So one is a fold and one is the fold frontal. And the difference between these files is actually the fold frontal has images of people looking directly at the camera with a 5-degree yaw on their face only, whereas the standard fold has all of the images with facial yaw reaching up to 45 degrees. So for my purposes, I chose to use the faces dataset, so the one that had been less pre-processed, because realistically, I am not going to be identifying the facial landmarks on a face and then realigning them for my images. And for the labels, I decided to go with the full dataset that includes the 45-degree yaw. because realistically, that's the sort of images that I will be working with. So it's better to train with that sort of data. Next, I wanted to verify the labels associated with these images, and I realized that the labels were all over the place. So specific buckets were provided, and then they also provided specific ages. So it was a bit confusing to understand sort of the methodology that they had used to label this data set. The other thing I noticed was that the 25 to 32 age bracket was the dominant, and the 60 to 100 was the second weakest. Now, a sample of images from each of the main brackets indicated that the labeling seemed appropriate. The width of the buckets also seemed to make sense, with younger age brackets actually containing fewer years, but actually there being more younger brackets, just because it's probably easier to differentiate between baby versus a child versus adolescent and so on. And then as you got older, the brackets for the ages got wider and wider. And ultimately, I think they decided to go with a 60 to 100 age bracket simply because they didn't have enough images of senior people to actually split these brackets down further. So I think that sort of logic is fine. But yeah, it was a bit confusing why they hadn't gone with, explicitly gone with brackets, and why they also had specific ages in there as well. Okay, one of the other things I was worried about with this data set was the fact that these images of people, when I had a casual look at the images folder, I found that an image of a person would repeat, and I was wondering how they would deal with that. So because in some of these albums, there were up to 800 images submitted in a single album. But I found that they've actually handled this by introducing a face ID for each unique face they had encountered in each album. So every new face they encountered, they assigned a new face ID. You don't have to worry about actually splitting this by album in terms of a K4 cross-validation training strategy. You can split it by the actual face IDs instead. And with the face IDs, most faces appear less than 50 times. The most that a single face appears is around 400 times, and that's restricted to a single album. So in terms of that sort of split, it's fine. Now, if I'm deciding to actually use this data set, then the age brackets are a bit of a problem. And what I need to do is somehow figure out how I can translate those ages into the ages that I want to use for my dataset or for my labels. Okay, so the next dataset that I looked into was the IMDb Wiki dataset, and I'm not actually going to spend a lot of time on this dataset. The methodology that they had used to create this dataset was clearly flawed. So just with an example of Rowan Atkinson, there were several images. Not many, so the majority of them were still of Rowan Atkinson, but there were several images that weren't of him. Some of them were children, some of them were female, and they were still attributed to him. And then identified that the most popular actor in the entire dataset was Jennifer Aniston, and with her, the majority of images that I found just in a sample weren't of her. They were of different people, men, women, children, etc., but they weren't explicitly of her. So their methodology is clearly flawed, and if I'm using this data to train my model, the ages associated with children are still, of that of the main actor that we're looking at. So that's just going to confuse our model, and so it's not worth training with this information because it's just going to teach the incorrect representations. So I've decided not to use the IMDb Wiki dataset. So the final dataset that I looked into was the Legenda dataset. Now this had a lot of data. The Legenda dataset actually consisted of the full image and a label file that provided you with the bounding boxes for each face and each body crop that it identified, or that they had identified. So there were around 340,000 images in total. But when you dig into the data set and you filter it out by actual ages and the where a facial bounding box is provided, because for my purposes, I'm mostly interested in the facial bounding box and not a body crop. You find that that reduces to about 84,000 images, which is still a significant amount of images. It's way more than the previous datasets that we had looked at combined when you exclude the IMDb Wiki dataset. So when you look at the age distributions, you will find that it's quite well represented until you get to around 70 years, and then it starts to sort of decline to 100. But apart from that, every other age category seems to be well represented in this data set. Now, in terms of the face crop that they provide, that bounding box is actually quite tight. It's still enough to age a person, but it is much tighter than the datasets that I looked at previously. It's much tighter than the mugshots that I actually collect. So if I'm using this dataset in order to train a model, then I'm going to have to go with a face detection algorithm that performs that tighter crop and pre-process the images into the format that matches what they have provided, which is not a hard thing to do. The face detection algorithm that I used to get my mugshots basically did the same thing. I just had to extend it, by 40% or whatever it was in order to see more of the person. So for the purposes of actually, testing, if I want to produce my own dataset and test it, all I have to do is just take the images that I have and just crop it down again to the actual face. So it's not a lot of work to do. It's actually quite easy. And I'm actually quite happy with the quality of the age labels associated with these faces. Like I said at the beginning, there was a very rigid strategy that they used to crowdsource this information. They were quite strict with their quality control, making sure that anything above a standard deviation of 4, a weighted standard deviation of 4, was not allowed through. So I am quite confident in the ages that they have also assigned to the faces. Now it's just thinking about how I can actually use this information. So in summary, the Adversarial, Adience, and Legenda datasets are good for my purposes. The issue with using the Adience dataset, obviously, is the way they have represented their labels with the age brackets. So I'll have to figure out how I would use that. Now, with the amount of data that is present in the Legenda dataset, so the 85,000 records, that's more than enough. It means that I don't actually need to use the Adversarial or the Adience dataset if I don't want to. But I feel like they would be a good test dataset if I can figure out how to work with the labels. Now, when I was looking at the other datasets, I was thinking that to make it easier for my human annotators when they're going through and deciding on the ages of the people in the images, I was thinking of using categories as well, just so that then they can just pick if it's a baby or a child or an adult or young adult or whatever, so that make it easier. So I still haven't decided on what I'm going to do next. My grandfather is actually coming tonight, so the plan is to stop here and think about what I want to do, and then pick this up tomorrow after I have picked him up. So we'll see what actually ends up happening. But yeah, I would like to use categories just so that it would make it easier for the human annotators. But if I have an age estimator, then it might not be necessary at all. So we'll see. I'll have a think about it, and then I'll pick this up tomorrow, and we'll see what I end up doing.